In this video, I will be presenting the second stage of the penetration testing, which is also called as network scanning. Basically, in the network scanning, we'll do more technical, we'll go for searching of the more technical details compared to the footprinting process. That means the network scanning is completely technical, where in case of footprinting, we'll also see the general technical content and also will search for the social material such as emails, websites, and the employee details and many other general things that are related to an organization. But in case of scanning, we'll go in more technical, especially to target the target networks and to know the various devices that are used in those networks and their IP addresses and many other technical things such as operating system details, and many other things. So it is more technical than footprinting, and especially to aim to identify the live hosts on a network. Live host in the sense the systems which are on and the operating system is running successfully. Such systems are said to be the live systems. Here we are going to identify the live hosts on the computer on the network, and not only the live hosts, but what are the open and closed ports on the network on the systems, because the systems has to communicate with any service or with any other computer with the help of sockets. Socket is nothing but the IP address plus port number. That is the reason we are supposed to check for the ports. Actually, these ports are the entry point into any computer. That is the reason the main thing that what we'll do here is we'll check for the open and closed ports. Next, after checking the closed and open ports, we'll go for checking of the operating systems in the network. And what is the current operating system running on? What is the version of the operating system? Once you know the version of the operating system and when that particular operating system was updated, this kind of information is known, then we can easily identify with the help of the operating system version and the last updated, is there any vulnerability present in that particular operating system. Once we know is there any vulnerability present in that operating system, then it is very easy for us to uh, use that particular vulnerability and to exploit that vulnerability to crack the system and to enter into the system. So that is the reason this particular operating system is information is also very important. Next one is service running on a network. What are the different services running on the network? Like the file transfer services, or maybe the file sharing services, or printer services, or time services. So this kind of services, what type of services running on the system? Because if you look at a printer service, whenever a printer service is running, there may be a common printer, but multiple computers may connect to the common printer. So here printer server may be a common server with which any other computer can interact, or which all other computers in the network may communicate with the printer. So that like that, what are the services that are running? There may be a common folder service, or there may be a file transfer service, or there may be a time service, network time protocol service. So whenever the computer connect to the server and server will update the time of the computers, or we can also say the whenever the client connect to the server will give the correct time information so that the client will update its time whenever it restarted. So these kind of services is which are running on on the network will be identified with this. That means so far whatever we have seen are so technical in nature. Next, what are the running processes on the network? What are the different processes running on the network, like maybe peer-to-peer processes, or maybe a distributed process, maybe any other process? And one more thing is to understand, to get the information about the previous things like live hosts, open and closed ports, and all. First of all, we should know what are the security devices such as intrusion detection systems, firewalls, and firewall settings that are used that have been used by the target system or target network Otherwise, we will not get the information such as what are the open and closed ports. So this security device information is also very important, because unless until you don't know the security information, that is security devices information, we cannot inject virus and worms that we have discussed in that we'll discuss in the next lectures into the target computer. Because whenever you build up your own virus script or the Trojan script, then the Trojan and virus script may be detected by the antivirus or security softwares that are installed on the target network. So the reason knowing of this security device and IDS is very important. Next one is system architecture. What type of architecture the target system consisting of? That means it may be a 32-bit architecture, or maybe 64-bit architecture, or maybe a legacy architecture which is followed by the web servers. So what type of architecture that was followed by the system need to be identified. Next, finally, once you know all these things, we can explore and identify what are the is there any possible vulnerabilities that we can explore and exploit using the information that are gained via previous steps. So the reason vulnerabilities is going to be identified by the help of scanning process. And how this particular scanning has to be done. There is a systematic methodology for this. The systematic methodology of the scanning is, first of all, we need to use a powerful tool, scanning tools. Either it may be Nmap or maybe any other scanning tools for performing the scanning process. In this performing of the scanning process, first step we need to do is checking for the live systems. First of all, we have to explore what are the live systems that are available on the network. Once the live systems are identified, then we need to check for what are the open and closed ports on the live system. Then we need to check for is there any intrusion detection system and security devices that are available on the live system. Then we need to go for banner grabbing. Then we need to go for scanning of the vulnerabilities. Then we need to prepare the network diagram. Then finally, is there any proxy devices that are placed in the network or not? Because proxy devices will look like normal devices only, but they will do the proxy operations like proxy HTTP servers or proxy internet servers. So these are the proxies will be placed in the devices. This information gaining is also very, very important for performing for identifying the chances via the proxy devices via proxy devices or via any other network devices that is available in the network, so that if you can identify vulnerability of any of the device, we'll have a sketch, or we can have a plan that how we can enter into the target network via these vulnerable devices, which are, we can also say, which are intermediate devices that are available in the network. So the reason the scanning methodology will follow like this. First of all, we need to check for the live systems. Then we need to discover the open and closed ports. Then we need to go for scanning of the target computer or target network beyond the intrusion detection systems. That means, is there any strict firewall settings available, or any other and malware or internet security softwares that are installed on the target network need to be identified. Then we need to perform the banner grabbing. Banner grabbing is generally a technique which is used to gain the information of the network services that are running on the computer on the network. That means it may be a network and the services that are running, and it's on the especially on the open ports, especially on the open ports. What are the services that are running need to be identified. This is called banner grabbing. For this, we may use the TCP scanning and many other TCP related scanning techniques via with the help of the scanning tools such as Nmap or something. So after banner grabbing, we need to perform the scanning for the vulnerabilities, and there will be vulnerability databases. We can go and check the possible vulnerabilities available in the version of the services and other network services that are running on the network or target computer, and we use that particular version to check for the availability of the vulnerabilities, and those vulnerabilities will be used or maybe exploited so that the target system can be broken. That means the hacker can enter into the target system. So finally, we'll draw a network diagram of that. If the number of computers are very less, then we can easily remember. And if the target network is too large, then we can draw a network diagram. Then finally, we'll go for proxies identification, so that because uh, having a problem in any of the intermediate device from the target from the hacker computer to the target network will may also lead to tracking of the or may also lead to the compromising of the entire network. So that is the reason in that proxies will also help us in diverting the traffic and to imitating the diversion of the traffic. So for this, we use these proxies. Usually, the proxies will be used, and whenever we identify as a penetration tester, we identify these proxies. Then we may take the help of these proxies to divert the traffic to the targeted network. So this is what the overview of the scanning. We will go in detail of this particular scanning now. In order to understand the scanning network scanning procedure, first of all, anyone must know the how this particular scanning will be performed with respect to the different layers of the protocol stack, different layers of the TCP/IP protocol stack. However, the whatever the application that you use, either it may be HTTP or FTP or maybe any other thing, at the application level must use any one of the protocol at the transport layer. In the transport layer, there exist two protocols. One is TCP protocol, another is UDP protocol. And this TCP and UDP protocols will be serving the services with the help of the sockets. Either they may use the different sockets for the TCP communication, and the socket in the sense here IP address plus port number. There will be specific port numbers with which the TCP communication takes place. So that is the reason. In order to scan what are the TCP and UDP services that are running on the computer, we must understand first of all the TCP communication. Whenever you understand the TCP communication, then we can also fabricate some packets, or we can give the signal to the target computer to respond to those packets and to respond to the requests that we have sent via fabricated packets, and can get more information about the TCP UDP services that are running on the computer. So, in view of this, it is very important to understand TCP communication. In the TCP communication, many first and foremost thing that we need to understand is TCP packet header. In the TCP packet header, if you observe, there is a source port, destination port. That means the sender's source port, sender in the sense who is the source with which from where this particular packet is originated, and destination is one where this particular packet has to reach. So source port and destination port, sequence number. Since the TCP is a connection oriented protocol, it will maintain the sequence and acknowledgement numbers to keep track of the number of packets generated at the source, whether all these packets are received at the destination or not. So sequence number, acknowledgement number, offset, some reserved bits will be there, flag. Here the window size, windowing size, checksum of the data, and urgent pointer and TCP other options will be available here. Among all these fields, this particular flag field is a very important field that we need to understand. This flag field will be like this. which is a 9-bit field or 9-bit flags, in which we have 9 different flags are available. Whenever if this ns flag want to set, then we need to set it as 1 and remaining all other bits should be set to 0. For example, if it is an acknowledgement packet and we need to set the acknowledgement flag, the first 4 bits are 0, the acknowledgement should be 1 and remaining 4 bits as 0. This is the way the flag should be set to represent an acknowledgement packet. And if you want to mention a finished packet, then all the first 8 bits should be 0. The finished packet corresponding bit should be 1. So this is the way how the this particular flag will be set in the TCP packet header. So this TCP control flags we'll see in detail. Flags in TCP bits are 9 bits. URG flag indicates urgency of the data contained in the packet, which is to be processed immediately. That is the urgency level of the packet to be processed. If the URG flag is set, then the packet is considered to be very urgent, top urgent, and need to be processed immediately. ACK is a flag which is to represent the acknowledgement of the receipt of the packet. SYN is a packet. SYN is a signal which is to initiate the connection between two hosts to facilitate the communication. In TCP, there exists three-way handshake communication, in which first any node wants to communicate with any other node, first will always send the synchronous signal. Upon the synchronous signal, the receiver will respond with the synchronous acknowledgement. So the reason synchronous is a signal which is to initiate the connection between two hosts to facilitate the communication. PSH is another flag to instruct the sending system to send all buffer data immediately, which is called push. All the buffer data which is available to be pushed immediately to the receiver end. Next, FIN flag, finish flag. This particular finish flag will be called or will be set when the sender feels that the sending of the information is completed. So tells the remote system about the end of the communication. It is to indicate that closing connection gracefully. This is called systematic connection, systematic closing of the connection between the sender and receiver, RST. This is the flag is used for the resetting of the connection. These are the TCP control flags that we will use especially for performing the scanning. And we use some tools, open source scanning tools. Sometimes if it is necessary, we may fabricate new packets with setting of different flags and will send to the sender. In response to that, sender may provide the response back. So after knowing these flags, we will go for discussion of the general TCP communication. The TCP three-way handshake. Since the TCP is a connection-oriented protocol, first of all, connection should be established to transmit the actual data between the sender and receiver. So the reason it is equally important, like TCP flags, it is equally important to know about the TCP three-way handshake. In TCP three-way handshake, if a client wants to connect with the server, first the client will set the state of the connection to the synchronous sent. That means the first of all, the synchronous signal will be sent to the server. Whenever the synchronous signal is sent, the server will listen continuously to the client request. Whenever the synchronous signal is received from so and so client, it will accept the connection and will create a memory. Will create a memory at the server end. At the server end, once the memory is created, the synchronous acknowledgement will be sent back to the client. So whenever the synchronous is received from the so and so client, the server will set its state as synchronous received, and synchronous acknowledgement will be sent back to the client. Whenever the synchronous acknowledgement is received by the client, it will establish the connection. That means it will also create a memory for this connection. So whenever the memory is created, then the particular client is ready for transmitting the data. So in order to respond to the synchronous acknowledgement after establishing the connection, the TCP, the client will send an acknowledgement signal to the server, saying that I have also created the memory and ready for transmitting the data. So acknowledgement will be sent to the server. Usually, these acknowledgement numbers will be like this: the signal corresponding sequence number plus 1 is the acknowledgement number always. Assume that here synchronous signal was sent from the client to server with the sequence number m. The acknowledgement number from the server to the client will be received like this. The acknowledgement number will be like the previous synchronous signal sequence number m plus 1, which indicates that the server is giving the acknowledgement of the synchronous signal m sent by the client. So this is the way the communication will be understood. Since the synchronous acknowledgement sent by the server is having the sequence number n, the client will send the acknowledgement sequence number as n plus 1 to the server. Now the server will understand that the client has sent the acknowledgement to the synchronous acknowledgement signal sent by the server with the sequence number n. Thereby, the server will accept the connection and will establish a connection between the client and server. Now the client will be ready for transmitting the original data, and server will also send the reply or acknowledge the receiving of the data. In this way, this particular communication takes place. So this is what the connection establishment phase. Once the connection establishment is done, once the client feels that sending of the data is over, then it will send a finish signal, FIN signal, as we have seen in the previous slide. Whenever it sends the finish signal, the server will come to know that okay, sending of the data by the client is over. Then server will gracefully close the connection. Thereby, once the connection is closed, no further data transmission takes place. If the client wants to perform to send the data transmission again or to make the data transmission again it has to follow this TCP three-way handshake first. Then the connection must be established. Then the data transmission should take place. So this is the way how the TCP flags and TCP communication or TCP three-way handshake will be helpful for establishing the connection between the client and server. Now we'll use these flags and this three-way handshake technique for performing the network scanning with the help of open source tools such as Nmap. Now we'll see how this particular scanning methodology need to be performed with the help of the open source tool, either it may be Nmap or any other open source tools. First, we'll understand the sketch of network scanning methodology. Then we can go for using of the tools. In the network scanning methodology, first of all, checking for the live systems. In this checking of the live systems, we may use ICMP, that is Internet Control Message Protocol, which is the protocol helpful in the in the network layer along with the IPv4 and IPv6. So this ICMP protocol will be used, ICMP scanning will be used, and we may also use ping sweep. Ping sweep is nothing but pinging a range of IP addresses in the network. Usually, a network consisting of a range of IP addresses, maybe subnets, maybe any other group of IP addresses that are allotted to the network. So we cannot go for pinging each and every system in the network to know whether the system is live or not. So the reason in the ping sweep method, what we'll do is pinging a range of IP addresses will lead to the ping sweep mechanism. Next, after knowing the live systems, we need to check for the open and closed ports. In order to check the open closed ports, we use the SSDP, that is called Simple Service Discovery Protocol based scanning, which will give us the what are the open and closed ports available. Once the open and closed ports are available, we'll check for the status of the port got in the result of the scanning. If it is open, that means the port is open, is available for anyone to use it or to connect it via the specific service that was mentioned in the scanning. Closed means we cannot use that particular, we cannot enter into that particular port since it is completely closed. Filtered, blocked, or dropping. It means that there exists some firewall settings which is especially uh, aimed to stop the traffic or stop the request coming onto the port for a particular specific port. So that means that particular traffic is filtered or maybe blocked or maybe dropped. So these are the three responses that we'll receive in the port scanning. In the port scanning, in the network scanning methodology, so this is the standard methodology scanning techniques that we are supposed to follow. The scanning techniques are broadly classified into two categories: UDP scanning and TCP scanning. In the TCP scanning, open TCP scanning, stealth TCP scanning, and third-party spoofed scanning. In the open TCP scanning, we use full open scanning. In the stealth TCP scanning, half open scan will be there, inverse TCP flag scan will be there, acknowledgement flag probe scan will be there. In the inverse TCP flag scan, Christmas scan or Xmas scan, finish scan, and null scan. And each and every scan will reveal a specific information. So that specific information will be helpful for us to understand the service level or service version that is running on. And with the service versions, we can come to know that what are the vulnerabilities available on the computer. Where in case of third-party spoofed scan, IDLE, that is idle scan or IP-IT header scan will be performed. So these are the various scanning techniques in the TCP purpose, in the TCP section. Where in case of UDP, we will use general UDP scanning. So in the next video, we'll see how these particular scannings will be performed with the help of Nmap tool.